These questions are coming from the Tech Active paper from 2023 for Maths Methods. So first we're looking at question 11. We've got a researcher found 17 out of 50 randomly selected people had used public transport in the last week. Determine the sample proportion of people who had used public transport in the past week. So we've got 17 out of 50, and so we just have to work that out as a decimal, and we get 0.34. Nice and easy 1 mark question. Then we've got to determine an approximate 95% confidence interval for the proportion of people who had used public transport in the past week. So we need to find out that standard deviation first, which is our square root of p outside of 1 take p over n. So we've got the square root of 0.34 outside of 0.66 over 50. When we work that out, we get 0.06699. We're then going to use that number and use our calculator now to go second vars. We're going to use our inverse norm. We're going to tell it the 95%, 0.95 for the confidence interval. Our mean is the 0.34, which is our proportion, and we put our standard deviation in there, and we're telling it to do the centre, and so it will then come up with that confidence interval for us of 0.208. 7 is probably enough decimals to go to, and 0.47129 there for our confidence interval. So then for part C, it says someone claims that 50% of people use public transport each week. Use your answer from question 11b to explain whether the data can or cannot support this claim. So it can't support the claim because when we look at our 95% confidence interval, we're going from 0.2 to 0.47. 50% is 0.5, so it doesn't lie in the confidence interval. Okay, looking at question 12, we've got a trig function there. We've been told it's cos, and we've got some information there to come up with the equation. So obviously we're going to start with looking at our amplitude. We're going from 6.3 to 8.5. So our amplitude is going to be our 8.5, take away the 6.3, and then divide by 2. So we've got an amplitude of 1.1. We want a mean value, so where it's halfway here. So if we do our 6.3 plus 1.1 or our 8.5 take away 1.1, we will get our mean value there, which is 7.4. And then we want our period, obviously, because so it's going from 0 to 12. So then we can get the b value from our equation by saying 2 pi on b must equal our 12. So 12b must be equal to 2 pi. B must be 2 pi on 12. So it is pi on 6. So we now have the amplitude of 1.1, mean value of 7.4, pi on 6 there. So then we can put our equation together and we get our y equals 1.1 cos, and we've got our pi on 6 t, and then that will be plus 7.4 on the end there. For part B of that, it says how long in the 12-hour period is the rate of change more than 0.55. So we need to find that rate of change, so we need the derivative of this one. So we're going to find the derivative of that. Obviously we're going to take that pi on 6 out the front, so we've got 1.1 times the pi on 6. Our cos is going to go to sine, and we'll put the negative in front there. And t. And so then if we want to just find out when it is more than 0.55, we can pop that into our calculator and graph it. So we've got negative 1.1 sine, negative, I'm going to put my bracket around there so I can put that together, negative 1.1, and I'm multiplying that by pi on 6, and then I'll put my bracket there to have that all together. Then I've got my sine of pi on 6. and that will be, might put a second bracket in there just to group that together. And put the X there. And then when I graph that, I may have to change my window because I've got a funny window in there. So I want to go between 0 and 12 because I know that's the period anyway. And I'm just going to change that between between -10 and 10, see if I can see my function a little bit better. And I'm going to go change that again to -2, 2 to emphasize that a little bit more. Now I can see that. I want to know when it's more than 0.55, so I'm going to put a 0.55 here. That's going to put that line in there. I'm going to want those two parts there where it crosses the line, so I'm going to use my second trace intersect. And for the first one, I'll just do enter, enter, enter. That'll tell me my first part is 8.42. Now I have got my, I was just checking, I do have my derivative written there because I would need that for part of my marks. I've got my 8.42 and 4188, and then I'll put my trace on. I'm just going to move my cursor over to the other side of that, then do second trace, intersect, enter, 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 and it should find that second one, which is the 9.57. 55812. So then I want the difference between those numbers. So I'm just going to go the 9.5755812, take away the 8.424188. That gives me 1.15139. Now that's in hours. I'll change that to minutes by multiplying by 60. That gives me 69 minutes. That it is over 0.55. The rate for. Always doing as much as you can on your calculator for these questions. Look back and go, I've got 3 marks there. I've got my derivative. I've got my 2 values that it's between. I've got the difference in hours. And I've got the minutes. And then I should go and answer and say the rate of change of water level is more than 0.55 meters per hour for 69 minutes out of the 12-hour period, just to make sure I've covered all my bases there. Now for question 13, we've got another 2 graphs and we're looking at intersection points of those. So we've got the 2 equations given to us, and we want to find those points of intersection. So I'm going to pop them into the calculator. So I've got x squared minus 4x plus 8, and I've got 10 cos of and x plus 10. Now I should have pointed out in the previous question and also this question, make sure your calculator is in radian mode. The previous question more obviously because there was a pi, and this one we are assuming we're in our radians there as well. So graphing our 2 functions, obviously I'm going to have to change my window. I need to see a bit more here. So I'm going to change that, my y's to go up to 50, see a bit more of that. And I can see that a bit more clearly. I could cut it and look at just between like 0 and 5 there if I wanted in my window, just to narrow down the section that we are looking at. And we want to find those 2 intersection points. So same as what I did in question 12, I can do the intersect there, press enter, enter, enter. That gives me the 3.472. So I've got 3.4724735, and its y coordinate is 6.168173. So that's one coordinate. And then I'll put my trace on and I'll just move my cursor over to the other intersection so that the calculator will work that one out next. So then when I do second trace, 5, press enter, 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 it gives me the 1.4414 and 4.312. Then in the second part of that question, in part B, it says state an integral expression representing the area enclosed by the 2 graphs. So we would be wanting to find the integral between 1.44, I'm just going to round to 1.44 there, to 3.47, and for those two equations. So looking at that, the one that is above the line, the dotted line, is our cos curve. So we're going to do the 10 cos of x plus 10, and we're taking away from that the x squared minus 4x plus 8. So we're taking that top line, find the area underneath that, and then take away the bottom one to find that area between the two curves that we are wanting. So that's worth 2 marks. We've stated that expression. We've kind of written in as much as we can there. So then determining the area between those two graphs. So I would take my blue one away first and just leave the red one there. Find that area between. So using the second trace 7, going between my 1.44 and the 3.47, and that's shaded in, and I get 16.88. And then I will take that equation out, put the quadratic one back in, x squared minus 4x plus 8, and then do my area between 1.44 and 3.47. And I might have to redo that because I think I typed in something wrong there. So 1.44 and 3.47, and that's shaded in now, and I get 9.23737. So when I go back, I'll do 16.88, and I'm taking away the 9.237, and I get 7.643. If I'd used all the decimals with my other one, I would have, if I kept all the decimals here, I obviously would have got a more accurate answer. So I probably should have left all my decimal places up here when I did the integral, and I probably would have got closer to 7.647, which is what's listed in the solutions. Hopefully there's a bit of leniency in the accuracy of those and how much you round by. If in doubt, keep all the decimals and only round at the end. I'll go on to question 14 in my next video.